Quality function deployment. Chapter objectives. Brief overview of the historical background of quality function deployment, QFD, and use of QFD as a planning tool. Understanding the benefits of QFD, how to capture the voice of the customer and organize the information. Understanding the structured process. Introduction. Quality function deployment, QFD, is a team-based management tool that uses customer expectations to drive the product development process. It helps identify and resolve conflicting requirements early on, ensuring customer satisfaction. QFD prevents confusion and misinterpretation as a product moves through different stages of development. By implementing QFD, organizations can incorporate the voice of the customer into the final product or service and identify new quality technology and job functions. Benefits of QFD IT goes beyond the usual customer response and focuses on defining requirements based on basic needs. It evaluates all competitors equally from both customer and technical perspectives and prioritizes the information using a Pareto diagram. The voice of the customer QFD focuses on understanding and meeting customer expectations. The customer's voice is important, and their expectations are determined through research. The goal is to reduce cycle time and bring a satisfying product to the market. Customer requirements are analyzed and translated accurately. Organization of information. Once the team identifies and researches customer expectations and needs, they process the information using methods like affinity diagrams, interrelationship diagrams, tree diagrams, and cause and effect diagrams. The affinity diagram is great for organizing lots of information based on their relationships. Affinity. The affinity diagram is a tool that helps gather and organize a lot of data based on their natural relationships. It's useful when thoughts are scattered, new solutions are needed, and support is important. However, it's not suitable for simple problems or quick solutions. A team of around 6 to 8 members with diverse knowledge is recommended. The process involves stating the objective, brainstorming, recording responses on cards, sorting them into groups, and choosing headings for each group. House of Quality is a key tool in QFD. It translates customer needs into design requirements and helps match them with organizational capabilities. It's a vital chart in quality planning. The House of Quality has different parts: customer requirements, exterior walls, technical descriptors, ceiling, the relationship between requirements and descriptors, interior walls, interrelationship between descriptors, roof, and prioritized descriptors, foundation. Understanding this structure makes other QFD matrices easier to work with. Step 1. In quality function deployment is listing customer requirements. These requirements can be primary, secondary, or tertiary, and are more detailed than the initial vague goals. For example, dependability is a primary requirement, and reliability, longevity, and maintainability are secondary requirements. Step 2 in quality function deployment is listing technical descriptors, also known as HOWs. These descriptors are engineering characteristics that directly affect customer requirements and are expressed in measurable terms. Primary technical descriptors are defined for each tertiary customer requirement, and further detail is added with secondary technical descriptors. It's like refining marketing specifications into engineering specifications. Step 3 in building a house of quality involves developing a relationship matrix between the customer requirements, what's, and the technical descriptors, how's. This matrix helps determine the relationships between the two, as each customer requirement can affect multiple technical descriptors and vice versa. It can get a bit confusing, but it's important for understanding how the different aspects of the product interact with each other. Step 4. In building a house of quality is developing an interrelationship matrix between the technical descriptors. This matrix helps identify the interrelationships between each technical descriptor. Symbols like solid circles, X, and asterisks are used to represent the strength and direction of the interrelationships. It's important to identify conflicting technical descriptors as they often result from conflicting customer requirements and require trade-offs to be made. Unresolved trade-offs can lead to unfulfilled requirements, increased costs, and poorer quality. In Step 5, competitive assessments are conducted to compare how competitive products stack up against the current organization's products. This is done through weighted tables or graphs that assess both customer and technical aspects. The customer competitive assessment focuses on each customer requirement and assigns ratings from 1, worst, to 5, best, to indicate how well each product meets those requirements. These rankings are then plotted for comparison. In Step 6, the prioritized customer requirements are determined by ranking each requirement based on its importance to the customer. The QFD team, or a focus group, assigns a rating from 1 to 10, with 1 being the least important and 10 being very important. These importance ratings help prioritize efforts and make trade-off decisions. It can be challenging because different team members may have different opinions on the rankings. In Step 7, the prioritized technical descriptors are determined by the QFD team. These descriptors are identified based on their importance in fulfilling customer requirements and the need for improvement. The team assigns a degree of technical difficulty to each descriptor, which helps evaluate the feasibility of implementing quality improvements. This degree of difficulty provides specific objectives for the design process and helps assess progress objectively. QFD process. In the QFD process, the House of Quality is the foundation for all future matrices. The technical descriptors are refined to an actionable level of detail by creating new charts, where the HRBUs of the previous chart become the whats of the new chart. This process continues until each objective is refined. The prioritized technical descriptors are usually carried along to the next chart to maintain target values and ensure the product meets customer requirements. Changing the target values would mean not listening to the voice of the customer, which goes against the purpose of QFD. The use of QFD charts depends on the product and project scope. An example of QFD's effectiveness is seen in the Toyota Rust QFD study, where corrosion warranty expenses were significantly reduced. By focusing on customer requirements like durability and no visible rust, specific design requirements and production processes were identified to achieve these goals. This included a 3-coat process with controlled process parameters to ensure the desired part quality characteristics. TQM exemplary organization. Sure, let me summarize that for you. Los Alamos National Bank, LANB, is the largest independent bank in New Mexico. Established in 1963, LANB provides a wide range of financial services to consumer, commercial, and government markets in northern New Mexico. It is owned by Trinity Capital Corp. With assets of $700 million, LANB has branches in Los Alamos, White Rock, and Santa Fe. The bank's senior leaders set the strategic direction and annual objectives based on detailed analyses of various indicators. Planning is a company-wide activity, and objectives are achieved through action plans involving multiple departments. LANB's Quality Council plays a key role in redesigning the performance appraisal system to align job performance with corporate performance. It's great to hear that LANB embraced online banking early on and that their customers are loving it. Their customer satisfaction rate of 80% is impressive, especially compared to their competitors and the national average. LANB's financial performance is also outstanding, with increasing net income and earnings per share. No wonder they received the highest quality award in New Mexico.